Welcome back, Digital Electronics. We're still hanging out in Unit 1, Lesson 3. This is one of the last lessons we're going to talk about here. Very important one that you need to carry out throughout your mechatronics career here. It's troubleshooting, all right? Being able to have the cognitive ability to solve a problem and, methodically come up with a procedure for yourself to get through, positions that you might get stuck in. You're going to hit this a lot soon here when we start doing a lot more breadboarding. And, being able to track down where you've miswired and those sort of things. Okay? So we're going to talk about a couple different methods and how you're going to walk through it. And, just kind of start giving you some sort of logical step to process through as you go through. Alright, so definition-wise, alright, troubleshooting. It's the process to isolate the source of a problem. Okay, something isn't working, and then we find out why it's not working, and then we're able to fix it. Sometimes we refer to it as debugging, but most of the time that's going to be associated with software programming. So later on when we do our BuildBots or we program our Arduino boards or use Quartus and do those boards or our Xilinx boards, we're going to debug, all right? And so it's the same kind of thing, all right, but it's more software related when we're debugging versus troubleshooting is more hardware related. So that's kind of the difference between the two. So we're going to focus, we just kind of wrapped up combo logic and sequential logic, very basic on the sequential logic. But, how we can process and how we can troubleshoot errors that might occur. All right, so there's three different aspects we can look at here. There's a design error. So the circuit works perfectly. There's nothing wrong with the circuit. It just doesn't meet the design specifications. It doesn't do the task that it's required. All right, the circuit's great. It's fantastic. Just doesn't do anything we asked it to do. That's essentially what it comes down to. If we have a build error, this means that the circuit was designed properly, but it was either built incorrectly or has bad components. That's going to be your error most of the time when we get into breadboarding. You're going to design it and work it and make sure that it's working correctly, because we're going to know that in multi-sim. You're going to be able to simulate it, and it's most likely going to be working for you. But when you start to build it, you wire things up incorrectly. All right, that's called a build error. Now, there is one design and build error. It's a combo one where both things are wrong. Okay, the circuit was designed wrong and built wrong, so it's not working in all aspects. Okay, so for us, we're gonna have to, be able to solve, step 2. And I'm gonna guide you in class when we do breadboarding or things like that. A couple different processes of working your way back through your circuit. One is when you actually wire it up, marking things off as you go so you know what you have and haven't done and where they're located on your breadboard. All right, but a very, very common one, main process that we're going to apply is called the divide and conquer process for solving the problem. So we're going to divide and conquer. So instead of trying to tackle the big picture, we're going to make it into small pieces that kind of make sense as we go and break it down step by step. Okay, so we'll talk about a little bit of an analogy here for the divide and conquer. So if we take a look at this example here, it says draw a single card from a deck of playing cards and try to determine what the card is. All right, so we're just kind of guessing, right? We're going to pull off the stack or the deck and see what happens. So an approach to be simply randomly guess one of the 52 cards in the deck, no particular order. Not a good idea, right? But if we took another approach that goes through sequentially, it would work, but it would be very tedious. All right, so divide and conquer is really this. We're going to assume the card is the 7 of diamonds. Divide and conquer would work as such. You would ask, is the card red or black suited? Hopefully we all know cards, and you might get an answer, all right, it's red. And then you would say, is it a heart or a diamond? Because those are the two kinds of red cards in the deck. You would get it's a diamond. And then you would ask, is it a face card or a number card? Remember, face cards are jack, king, queen, or numbered card. So you get the word that it's a number. Then you would ask, is the number, below 5? And you would get a no. So that means, all right, is it odd or even? Okay, you would get that it's even, or I'm sorry, that it's odd, and then you narrow it down to the 7 or 9. Say, is it the 9? No. So divide and conquer, we're just breaking it down. We're taking the big picture and chopping it into, what do we know? The deck has 52 cards. We ask, is it red or black, and we get that it's a red. That automatically goes from 52 down to 26. All right, so we're constantly cutting down the number of possibilities that could be. In your circuit, you can take the same approach. Sometimes it's, as simple as you've seen me already do it. Hey, is the logic gate working? If I do this and this, am I getting this signal out? I'm just taking a small step to make, you might have 4 or 5 chips on your breadboard. Well, let's see, hey, is the inverter working? So if I put this in, do I get the opposite back out? Test your switches. Are your switches working? Can I turn on a light and turn it off? So just different things like that. The little things that you go through. That's why I say, when you're breadboarding, most important thing is, but when you put your ICs in, do all the power and ground first. Don't come back to it. Have a method to what you do. So when you troubleshoot, it makes it easier. Also, when I've talked about breadboarding, don't make big loops with your wire. It's harder for me to come over and help you, and it's harder for you to troubleshoot later on. So these are things that we can, divide and conquer on early. Always power and ground your chips, and make sure that you have your wires laying as flat as possible, so it's easier for us to come over and analyze what's going on. So it's more or less, you're going to kind of reference a flow chart. Now, you're not always going to have the flow chart sitting right next to you, but you need to have this thought process in your head. So we're going to get up, right? We're going to build our circuit, and we're going to test it. We're going to test it to determine if it's working correctly. And then you ask yourself, well, is it working correctly? Yes. Good, we're done. We get checked off. We've learned. Now, no. Okay, we have a whole different. Recreate the fault. In what cases is your circuit not working? So when we start toggling through, inputs, and we go 0, 0, 0, 0, 0, 1, 1, 0, 0, or we go all the way up to 1, 1, 1, or things like that. Which specific case is it faulting out at 0, 1, 1? Is it faulting out at 1, 0, 1? Are some of your readings correct and some of them not? So recreate that fault, all right, and then we can use a probe to go through it. We can use the multimeter, and we can see what's miswired in that step. So I want you to think about that. Put yourself in that error situation and take all of your readings as you go through that error. All right, where did you miss? Why you're expecting a 1? Why is it giving us a 0? All right, so there's a couple different things. Is the logic gate bad? Did I miswire something? All right, a couple. Just take different approaches. Oh, the wire's coming from the wrong location. It's not even coming on. Well, did I remember to power and ground the circuit? So, just different things like that. Find a method for how you're going to approach each one of these. Okay? Sometimes you work forward, sometimes you work backwards. Kind of depends on the scenario. So you want to make sure that, when I turn switch 1 on or off, is the signal coming out a 0 or a 1? And then is that correct? Is the logic gate reading the signal incorrectly but putting the wrong signal out? Like, is the chip fried? Or is there a short in the breadboard? Did I grab the right chip? All right, some of you guys, we've already run into that with breadboarding. I accidentally wired up the AND gate as an OR gate and vice versa, and that completely, conflicted all your problems. And that was one thing where we know, oh, well, we should have been getting, 101 should give me a 1 here, and it's giving me a 0, or those sort of things. So you gotta think about, do I have the right chip in the right location? So think about all these things. You need to be able to take this, and work backwards. I'm going to teach you how to trace through your schematic backwards with a logic probe or a multimeter, so that you can say, follow the signal be like, oh, these should both be high in this situation. One is, one isn't. Well, why is this one not high? Why is it low? And you work through it methodically, but you put yourself in the fault situation where it is bad, and then you trace back to where you miswired or misconnected, or eventually all those don't work out. Is the chip bad? And you do a basic circuit to check the chip. Very, very simple things. So, but it might take you a few times through. Sometimes wiring something correctly creates a fault in another part of the program that you miswired, or another part of your breadboard that you miswired. So, you just gotta be careful, but do one step at a time. Don't take everything off your board and start from scratch. Come up. It's actually very gratifying when you guys, you get an error or something. Like, nobody's happy to get the error, but when you solve the error, all right, you get through it and you've troubleshot and you've found the problem and you were able to fix it. Sometimes we forget. You guys, going with some of you guys breadboarding, you forgot to put the battery on. You're like, it's not getting power. Why is it not working? And just a simple, hey, look at your breadboard companion. You forgot to put your battery on. Just sort of simple things like that. Sometimes you get so wrapped up in the process that you leave something behind. It's so simple. And all you got to do is, fix it and look back and laugh at yourself, and then you learn from last time. It's awesome when you make mistakes and you learn from your mistakes. Because it teaches you to think. I don't want you guys to all get your circuits right on the first try. It's great, it's awesome, but it doesn't necessarily teach you to think. I really want all of you guys to get errors the first few times, and I mean that in the nicest of way, because I really want you to think through a process and how to solve it. Okay, it's not all design development. It's creating that thought process in your mind that you can solve problems. And once you understand how to solve problems, it helps you become a better engineer from a design aspect, because you're like, oh man, this could go wrong, this could go to the... You start thinking of scenarios that when you engineer something that you want it to not have happen. So it's really key. All right, we're going to do a lot of troubleshooting on these courses, but that's where your thought process and your thinking comes in. All right, so keep this flow chart in your mind. All right, you don't have to write it all down and that sort of thing, but it's a process that you're going to go through. All right, well, that's it I got for troubleshooting. I will see you guys in class, and we'll be working on labs.